exercise solutions for data science, and there aren't. The authors didn't provide sample solutions either for this version, the second edition, or for their first edition. But if you, I don't remember who said it, but if you Google around, there are various people out there who have started to develop their own sample solutions and post them. So you can look at those. I won't tell you not to look at those. That's a good idea. Look at other people's solutions. But like I said before, you might see different variants of solutions for the different exercises given by different people, and that's not necessarily a bad thing. People have different styles. But at the end of the day, you should be critically assessing those sample solutions, not taking them at face value. When you see one, type it out yourself, play with it, see how it works, see if it actually does what it's supposed to do. If there's a particular exercise that you want to ask me about, because you're interested in how it would be solved, just get in touch over email. You can also try asking your TA. I'd be happy to have a go at it. Okay, let's talk about the last two kinds of data manipulations that we're going to do today. And the first one is mutate. So mutate is what you do when you want to create a new variable, a new column in your data frame. And it's usually that you want to create a new column based somehow on calculating or manipulating existing columns. That's why it's called mutate, because it's the idea to take something existing and mutate it into some new form. It always adds variables to the end of the data set, to the end of the column. If you want it to appear earlier, of course, you can move it, you can rearrange it. But it always, by default, adds variables to the end of your data set. I don't know if I've said this out loud, but it's in the notes. There is an easy way of viewing your data frame in R using the capital view command. So, where is it? You know, when I type flights, I get this sort of first 10 rows, and I can type glimpse flights, and I get it in the other way. If I type capital V view flights, then it brings it up in this kind of like a Microsoft Excel spreadsheet-like format, which is really handy, actually, to sort of browse around using your mouse. You can scroll all the way down. Maybe. It's a big one, yeah. 11,000 rows, all the way down, 281,550. And you can scroll across all the columns. And you can even sort by these different columns relatively quickly as well, just for viewing purposes. It won't change the data frame down here. This is just for viewing. So that's a handy way of looking at a variable in R using capital V view. So let's do an example. Let's do the following. Let's say we first want to chop out a chunk of the full data set so that we have fewer columns to make it easier to see how mutate works. So let's make a new data frame called flights_small, and we'll set it equal to the following. We'll select, remember select chooses columns, variables. We'll select from flights, everything starting from year, ending with day, everything that ends with the word delay, the distance column, and the airtime column. Why did I choose those ones? I have no particular reason, just for demonstration purposes. So let's get to that, and we'll say flights small equals select flights, comma. Now notice in the slide I've separated that big command into multiple lines. That's a convention you're going to see in the R for Data Science book and probably out there on the internet. It just makes it easier to read, and R doesn't mind if you separate things out. If you just hit return without doing a closed bracket, it'll show a plus. That's just its way of saying, okay, I'm still waiting for the next thing. Year to day, comma, ends with delay, comma, distance, comma, airtime bracket. Okay, so I've done that. I've selected just those columns. And if I look at this new data frame, that's what it is. That's the first 10 rows. It still has 336,766 rows. So it's all rows, but it's just a subset of the columns now. I mean, by the way, I could have typed this command by putting everything in one line. Year to day, comma, ends with delay, comma, distance, comma, air time. I could have done that. There's no reason why I couldn't have done that. It's the same. Oops, except I might make a typo. Year to day. It accomplishes the same thing. But imagine if I had like 20 different things I was doing. That line would become really, really, really long, and I wouldn't be able to see it all. I'd have to like scroll around in my console, which is just a nuisance. It's just easier to do it like this. It's more readable. Okay. Anyway, that's what we have now. Let's create a new column called gain that tells us how much time each flight made up between the departure delay and the arrival delay. So if it was delayed on departure by 20 minutes, but the arrival delay was only 10 minutes, then it made up 10 minutes during the flight. The pilot decided to gun it to try to make up the time. They're usually not allowed to do that because it burns more fuel and it costs the airline more money. They absolutely are able to do that. Like on most commercial flights, the plane isn't flying as fast as it can.
I was just wondering, how come some of the numbers in the table are red?
Okay, so the question was, how come some of the numbers in the table are red? That's a good question. It looks to me like they're all negative numbers.
So it doesn't pertain to any function?
I don't think it pertains to anything that I did. No. That's interesting. Did it just start doing that? Or was it doing that before? I don't remember.
I think it was doing that before.
It was doing that before?
Yeah.
Okay. Yeah, I guess it's coding negative numbers in red just for visualization purposes. Yeah, I hadn't noticed that before. All right. Yeah, the plane flies at an optimal speed so that it balances speed with not burning as much fuel as it could by going faster. But like Toronto to Vancouver, you could arrive like half an hour earlier if the pilot gunned it a little bit. All right. So let's also add a column that computes the average speed. Oh, I didn't actually do this one yet. Sorry. We're going to add a column called gain that tells us how much time each flight makes up. So we're going to do that like this. We're going to say mutate. That means create a new column. We're going to put it in flights small, and it's going to be this. It's going to be called gain. The title of the column is going to be gain. Now we use a single equal sign because that is an assignment. We want this new column to be equal to the departure delay column minus the arrival delay column. Mutate flights, comma, flights small. I'll just type it on one line. Gain equals departure delay minus arrival delay. Oh, I have to spell things, right? Mutate. There. So now I have this new column, gain, which is departure delay minus arrival delay. 2 minus 11 is minus 9. 4 minus 20 is minus 16. 2 minus 8 is minus 10, and so forth. So for each row, it takes the departure delay value and subtracts the arrival delay value and puts that in this new column called gain. Does that seem straightforward? Good. Let's say we also want to add another column that computes the average speed of a flight. Distance divided by air time. So We can tack on multiple arguments to mutate at the same time if you want to add more than one column. So let's do it like this. Mutate from flights. Gain equals departure delay minus arrival delay, comma. Speed equals distance divided by airtime times 60. And now we have this column called speed. So the name of the column can be anything you want, almost. Actually, I don't know what happens if you try to use a name that already exists. Let's try using, I don't know, day. Let's see what happens. No, it doesn't complain. It just replaces the existing column. Oh. So I said, call this gain day instead of gain, and it just overwrote the existing day column. So that's something, yeah, something you need to know about. It won't say, oops, are you sure? There's already one called day. It'll just say, fine. Yeah.
So, you know how the one that we used specifically was a data thing that we selected specific columns to use?
Yeah.
So could you also use mutate on columns that we didn't select?
No. So on this flight small tibble that only contains these columns, those are the only ones you're allowed to use in mutate. Yeah, if you want to use variables that were in the full data set called flights, then you have to mutate on the flights data table, not on this smaller version. Yeah. So that first argument to mutate is what you have to play with in that mutate command. Okay, so let's do that again properly without replacing day. There, and then gain, and then speed. Good. Now I didn't assign the output to anything, by the way, so it hasn't been saved, which you would probably want to do. Any questions about mutate? I mean, I think it's pretty straightforward. You can just create any number of columns you want, and they have to be based on some logical or arithmetic operations on existing columns, or they can just be other stuff. Let me show you an example. Like I could say mutate flights pizza equals 12. Okay, good. Now I have a new variable called pizza, and it's equal to 12. That's not particularly useful, but that's just to point out it can be anything. Yeah?
So we know how earlier you said that the capital view command?
Yes, capital view command.
With the mutate, so we can view the mutated one up there?
Sure, yeah, we could do that. So in this version, I haven't saved the output to any particular thing, but I could. So I could say, let's get our original command back. I could say flights small equals mutate flights small. So I'm replacing flight small with the mutated version where gain is that, speed is that, and now I can view flight small, which I tacked on two new variables to, and there they are, gain and speed. Yeah. So as long as I save the output of the mutate command to a variable, and it can be the existing one, which will be then replaced, or it could be something new, then I can continue operations on that in the future or view it. Yeah. That's a common gotcha at the beginning of R programming, is that you'll do these commands like mutate or select or filter, and you won't assign it to an output variable, and it'll print to the screen like this, the result, and you'll say, oh, well, I did it, it's correct. Where is it? I don't know where it's gone. And that's just because you haven't assigned it to a new variable to save. Okay, other questions about mutate? It's also not rocket science. Okay, if you only, this is a weird one that you might see, if you only want the new columns and not the old ones, you can use transmute. Transmute will take your data frame it will create 2 new columns and just give you those 2 new columns without all the old ones. When would you want to do that? I don't know. Maybe you would. And you might see that in your travels with R code. So transmute is just like mutate. It will create these new columns, but it will only give you the new ones. It will not give you the old ones plus the new ones. It will just give you the new ones. You can achieve the same thing, of course, by doing mutate and then what? Yeah.
Select.
Yeah, if you did mutate and then you selected just the new ones, that would be the same as just a transmute. Exactly. Okay, that's the end of mutate and transmute. It's not very, very difficult. The last one is summarize, and this one can trip people up a little bit. But it's also not conceptually that difficult. Basically what it does is it collapses a data frame down to a single row. So for example, if I said summarize from our flights data frame, create a new variable called delay and make it equal to the mean of the departure delays, and remove any missing values from that calculation. So na.rm, that means not available, remove. That means remove the not availables before you do this mean calculation. If you don't do that in this case, when you call mean, then any NA values will contaminate the calculation, and you'll just get NA. Yeah?
Sorry, can you re-explain, you said that we're taking delay, and then what are we doing with mean?
We're making a new variable called delay.
Okay.
That's equal to the mean of the departure delays. And so when we do that, we get a single number, 12.6. So that's a huge reduction. We've taken a data frame with 336,766 rows, and how many columns do we have? 19 columns. We've taken that giant data set and we have one number now. And that's because that's simply the mean of all the departure delays. All 336,000 of them, where the NA values have been removed. So that's not a very useful thing to do. Although maybe you want to know what the average departure delay is in 2013 of all flights from New York City airports. But summarize is much more useful when we pair it with this other command called group_by. So !group by, what does it do? It groups your results by one or more derivatives. Here's how it works. If we say by day equals group by flights, comma month, comma day, and then on that element we summarize and we create delay equals mean departure delay. Now instead of getting one number, we get one number for each day in that month and for each month. So there's 355 plus 10, 365 rows. There's one row for each day. So now we're computing the mean departure delay for each day of the year because we group by month and day. On any day of the year, there's multiple flights that leave those airports, and each of them have a departure delay. And now we've computed the mean departure delay for each of those months and day. So we apply summarize to the result of this group by command to achieve that, and we get 365 rows. For each month and for each day in that month, we get an average departure delay. We could do it just by month and ignore the day if we wanted. Now we just get 12 values. So we group by flights, comma month, and then we summarize on that. Delay equals mean departure delay. And now we get 12 values, one for each month. So it's the average departure delay in each month. So it's a little bit of a complicated code, but I think you see how it works. We could create a nice bar plot if you want. We can do multiple things. So before we go on, are there any questions about the combination of group by and summarize? It's a two-step thing, yeah.
I just got lost a little bit, so that's
Okay.
not, but if maybe
Yeah.
rephrasing a little bit.
Let's repeat it then, because it is
Okay.
a bit complicated, and it's the end of the class, and we're all tired. So why don't we start with a question? Like this, so we summarize in the whole data set, flights, and we ask for the mean of the departure delay column. We get one number, we get the average departure delay on all 336,000 flights in the data set. What if we wanted the average departure delay for each day of the year instead? Well, actually, let's do it for each month. Let's say we want it for each month. The average departure delay in January, the average departure delay in February, and so forth, all the way to December. So there's 12 months, and the month is denoted in the data set by the month column, which is an integer, starts at 1 and goes up to 12. So the idea of combining summarize with a group by, what the group by does, you can visualize it. Imagine all 336,000 rows. Some subset is going to be just January. I don't know how many there are. We can use filter to find out. There's going to be some number that's February. There's going to be some number that's March, and so forth. So what the combination of summarizing and group by does, the first step kind of, you can visualize that whole data set and visualize like separating it out into January, a whole bunch that's February, a whole bunch that's March, and you separated it out into 12 chunks. And then the summarize command operates on each of those 12 chunks and gives you 12 results. So let's jump to that example. So the group by command is the thing that kind of slices it up into different groups. And what are we grouping it by? We're grouping it by month. So we're going to end up with 12 different groups. And then we take that thing that's the group by month, and we pass that to summarize. And we ask for the mean departure delay of that grouped version of the data set. The slightly difficult thing is the following. If we type this in, by month equals group by, take all of our flights, and we want to group them by month. If we try looking at that, it just gives us something that looks like the same thing as the flights, right? There's no sort of way of telling what it is, except that it has this extra line that says groups, month, 12. That's the little signal to you that, this is not just the flights data set. It's the flights data set that's being grouped by month. I guess R has no way of sort of visually showing you that it's separated it out. But that's what's happened. So then if we apply the summarize command not to flights, but to the group version of flights that we just created. And it's delay equals mean of departure delay, comma, and a dot rn equals true. Then it applies that mean operation here, the average of the departure delay column. It applies that to the group version of the data, all 12 different groups, and it gives you the output, one group per row. Does that help? Yeah, it is a bit of a confusing thing. And so that's where we group by a single variable month, and we get 12 values. But you can also group by multiple variables. And that's what I showed here. I should show them in their other order, because that's a simpler one. We can group it by day of the year, by saying, I want my group by to operate on the month and on the day. So month goes from 1 to 12, and for each of those 12 months, there's a day that goes from 1 to 30, or sometimes to 31, or maybe to 28, if it's February. So now instead of 12 groups, I've got 365 groups, one group for each day of the year. And now I'm applying the mean operation, the mean of the departure delay column of each of those 365 groups, and it's going to return it as as a 365 row result. Yeah.
What if you were to, like, if you're looking at the day, but you, in the group by, you did not include months? Would that make a difference?
Yeah, that's a good question. Yeah, this is probably it's a slightly misleading name for a variable. So the question was, what if we tried to group by day, but we left out the month? Let's do that and see. So let's say by day equals group by flights, comma day. And now let's do summarize by day. We get, where is it? 21 plus 10, we get 31 rows. So why do you think we get 31 instead of 365?
I think it takes an average of the day, but from each month together, as opposed to looking
That's
at it.
right. It's not
as a month.
distinguishing between the different months. It's just taking all, let me get the flights back on there. Flights. It's taking all cases where the day is equal to 1. And that could be in month 1, month 2, month 3, month 4, month 5. They're all day equal 1. All the first days of the month. And it's doing the mean departure delay. Then all the second days of the month, regardless of what month it is. And it's computing the average departure delay. So we're getting departure delay averaged across days of the month, regardless of what month it was. Does that make sense? Good question, though. Okay, other questions about that combination of summarize and group by? Yeah.
What other arguments can we use besides mean?
Besides mean, there are lots of them. The basic answer is you can use any arithmetic or logical command you can think of in R. You can do anything. Yeah. Anything that you can calculate, basically, you can put in there. You can compute counts, like the number of things that are true. You can do standard deviation. You can make up your own formula. Anything you want. Okay. We talked about these different verbs, these 5 different verbs. What were they? Filter, select, mutate, summarize, arrange. Right, arrange. And we saw how to use them individually. So most often you're going to actually use several of them in sequence to achieve some result that you want when you do an analysis of a data set. So here's an example. I'm sorry the font is a little small. Multiple wrangles. Let's say we want to compute, what do we have here? We have distance of the flight on the horizontal axis. We have delay on the vertical axis. And each dot is sized by the number of flights that occur at that distance and that delay. That's kind of complicated. What do we have here? We're grouping by destination. And then we're applying summarize, where we count. So count equals n. So n is one of these commands you can do. N just counts. Mean, we're taking the average distance. Delay, we're taking the average delay, or the arrival delay, the average arrival delay. And then we're, this is a terrible example. I don't even remember why I did it. I think just to demonstrate you can string these together. Then you're going to filter those delays where there's at least 20 of those flights and the destination is not Honolulu. I must have been... Oh, I know why I didn't want the destination to be Honolulu, because that's like an outlier. It's like a super far away flight compared to the other flights. Because they're all flights in the U.S., but like Honolulu is not exactly in the U.S. So it would be like this huge distance out here. That. Let's not look at that. It's too late in the day. But let's look at this one thing. Oh, I know why I wanted to do this in part. To talk about the pipe operator. That's an ironic word. Okay. So here's an example where I string together a bunch of different of these verbs. So group by, summarize, filter, and then ggplot. And I do them by writing the command and then assigning the output to a new variable. And then I summarize that new variable and assign the output to a new variable still. And then I filter that new variable and assign it to the same variable name. So each time I kind of have to invent a new variable to put the results into, and then invent a new variable to put the new results into, and I kind of build up all of these variables along the way, which is arguably a bit of a messy way to go. So in R, they invented this thing called the piper operator, which essentially lets you string together these different operations, one after the other, without having to save these intermediate variables. So now I can say delays equals flights, and then pipe. That means, and then group by destination, and then summarize, and then filter. So the piper operator is kind of like saying, do this command, and then pipe the results as input into this next command, and then pipe the results of that as input to the next command, and then pipe the results of that as input into the next command, and so on, without having to save each result into an intermediate variable. So it lets you string together a whole series of commands without having to do that. And so you're going to see that kind of code in R, for sure in the R for Data Science book, and in general as you go. And here we've done all that piping of these different data wrangling commands and assigned it to delays, and then we ggplot data equals delays. We could even replace that by getting rid of this delays and just saying flights, piped group by, pipe into summarize, pipe into filter, pipe into ggplot. We can even pipe into a ggplot command without having to say data equals. If you pipe something into ggplot, it assumes what you're piping into it is the data set. So you'll see that kind of code as well, where you have a whole series of operations on a data frame that mutate things and filter things and select things, and then eventually even pipe it into a ggplot command. Okay. So other useful functions for summary is, we saw mean. You can also do median, standard deviation, min, max, count. You can even get quantiles. And there are some others you'll see in the R for Data Science book. Okay, I think we basically reached the end. We saw these 5 verbs, and summarize. Summarize is usually always paired with group by. The homework for this week, which will be due next week, is basically doing this kind of thing. Taking some example data and answering various questions by applying one or more of these verbs to manipulate it. Okay, before you go, are there any final questions? You'll absorb this all much better if you actually go and practice and try it out by typing stuff in, and the homework will help you do that. And there will not be any complicated questions on the exams about, well, like this and something. That's not going to be on the exam. That's not like that.